Hello everyone. In this session we are going to talk about complex numbers and okay, let's get into it. What a complex number is, it is a number that has imaginary part. And what's the imaginary part? Okay, let us go back to a square root of something. What is the square root of, let's say, 4? It is 2. Why? Because I know if I multiply 2 by 2, it will definitely give me 4. And it is very simple. If you have a square with, let's say, sides with 2, if I multiply it, this area would be 4, whatever, let's say meters, it would be 5 meters. If it was 16, it would give me also 16. The problem begins when I have a negative number. 1, I know the square root of 1 is 1, because if I have a square and the sides are 1, the area would be also 1. But what if I have a square root of minus 1? Does it mean anything? I mean, can we have a square and then it is maybe not in this direction, but it is in other direction, like this one? What does it mean? It doesn't have any meaning, right? No, it does. And the thing is, the square in our real world, it is just in that surface and we are looking upward. But in imaginary numbers, and minus, for instance, 1, it is to the surface. You should dig the earth and find it. It is a little bit inside the earth. So it has a geometrical meaning, but we still don't know what to do. Let's go to quadrants. The first quadrant and the second quadrant, and so on. Let's say here is positive and here is negative. And in one change of direction, I can go to negative side. Let's say we are talking about cosine here. And what number multiplied by itself would give me would bring me here? It is not a number, it would be an element, and that element would be the... Okay, I know only one way to come from plus to minus, and it is just by a straightforward one move from here to here. But I cannot multiply by itself and still get a positive and still get a negative sign. So the problem might be solved by imagining, okay, I come from here to here in one move, and a second move coming from here to here, I land exactly where I want, but I do not have a name for it. So it is going to negative direction, but it is not negative, and two of them would give me a minus 1. So maybe it is half of negative. So instead of two big halves of minus 1, I have two half of minus 1. And since there is no half of minuses, we call them imaginary part, imaginary number. So right now I say, okay, my problem is solved. Minus 1 is multiplication of I by I. So 2 times I would give me minus 1. Not 1 time. 1 time is just the half of the move that we do not have any name for it. This is just I. We do not have any number for it, sorry. Now I have minus 4. This should be a little bit more interesting. So how can I solve this one? Maybe it is 4 times minus 1. So it would be 2I again, solved easily. But is 5 also a complex number, just like this one? Yes, it is also a complex number. It is 5 plus 0I. It is also complex. So now we have a set that is actually a field, and it is field of complex numbers, because we have even more numbers than integers and real numbers and everything. So it is a field, so we need also a neutral element. If I multiply by it, it would give me a unit vector. This is called complex conjugate. And it uses to nullify the imaginary part. Imaginary is the I part, and this is the real part. How do we do that? It is, for instance, my thing was, let's say 2 plus 3I. The complex conjugate of it would be 2 minus 3I. Let's draw them on axes. The real part goes to the x-axis. It is 1, 2, and the imaginary part we will draw it on y-axis. It is 1, 2, 3, 1, 2, 3. The complex number is here, and its conjugate is here. So for conjugate we only change, let me write it with another color, to minus 3I, and this is the conjugate. Another example is minus 4 plus 2I, or minus 2I. Its conjugate would be minus 4 plus 2I. So it is 1, 2, 3, 4 plus 2I, and this is minus 2I. But why do we need the complex conjugate? You may remember that we might want to show we have an inverse of an element of a number to show it is a field. It would be very handy in our calculations later, but just for now, let's try and see if we can calculate it. But before we go to that, we need to see what would happen instead of adding these two together. What would happen if I multiply a complex number by its conjugate? Okay, what was the first example? 2 plus 3I multiplied by 2 minus 3I. 2 times 2 is 4. 2 times minus 3I is minus 6I. 3 times I multiplied by 2 would give me 6i. And here's the tricky part. I have a minus, I have a plus. It is minus 9 times I to the power of 2. Here is most of the students make mistake, and is that they calculate everything alright, but when it comes to minus 9i2, it is a little bit confusing. So my suggestion is you write minus I and then its power, but use it in brackets so you wouldn't make mistakes. So it would be, and again, I times I would give me minus 1 plus minus 9 multiplied by minus 1, 4 plus 9, and the answer is 13. So multiplication of a complex conjugate by its complex number would give me a real number, and the imaginary part would vanish. I want to just mention, this reminds me of a plus b multiplied by a minus b, which would give me a to the power of 2 minus b to the power of 2. And yes, but remember, here for complex number, you do not always need to multiply every number by its conjugate. Just remember it is a to the power of 2 minus b and then I, both of them to the power of 2.